Hi everybody, hope you're doing well. Welcome to week 7 of the 4th marking period. This is the third section of Unit 6 in Survey of Math, and this will teach you and review how to interpret and find some information regarding box and whisker plots. So this is going to build off of the first lesson that we reviewed a week ago, especially with finding information like medians and quartiles. We're going to go over some basics on how to find those values again, and then we'll take a look at a handful of problems where we'll do some basic interpreting to find information about box and whiskers. So we use box and whiskers to visually organize data into quartiles, so breaking things into 4 pieces, each containing approximately 25% of the data. Box and whisker plots are created from what's called the 5-number summary. So as you can see listed out here in the little blurb above, that 5-number summary is consistent of the the minimum, the lower quartile, the median, the upper quartile, and the maximum. So we're going to briefly go over how to find those values first, but again, most of this will be focusing on interpreting an existing box and whisker. So here's a list of data. It doesn't really matter the context of it, but again, if you are asked to do anything with a data list, make sure the numbers are in order. As you can see here, that's already been done for us. The easiest 2 things to find as part of this 5-number summary should be the minimum and maximum. The minimum is the lowest number, which is 2. The maximum should be the highest number, which in this case is 35. Remember, before you find the quartiles, as we reviewed last week, you need to find the median first, okay? So, again, if you need to do this visually, cross out lowest and highest, and work your way until you hit the middle. You can see exactly that's how I'm doing it here. So I end up with a pure middle of 12 once again, which is nice. So again, for visual sake, I'm going to keep that circled. You should probably box it or something. So again, you know that's the median, because to find the quartiles, I'm then going to focus on the left side and the right side. So if I look for the Q1, the lower quartile, left of the median, I have 8 numbers. That means I don't have a pure middle. My middle would have to be between the 5 and the 8. So to find the Q1, I'd have to add up the 2 closest numbers to the middle, 5 and 8, then divide it by 2. This is probably math that you should be able to do in your head, but if you're going to punch it in the calculator, please make sure, add the numbers, get that answer, which is 13, then divide by 2. Otherwise, your calculator is going to do probably some bad PEMDAS. You get a Q1 value of 6.5. The right side, again, I have 8 numbers to the right of the median, so my upper quartile is going to be in between 18 and 20. So I'd add it, divide by 2. My Q3, my upper quartile, is 19. So that's how you find what's called the 5-number summary, and that's what would allow you to make a box and whisker plot and do some interpreting with that. So let's go ahead and apply that to a handful of word problems here. So you can see another example of a box and whisker here on this screen. Again, each piece of a box and whisker is 25% of the data. One thing to remember is that just because they're each the same percentage does not mean they're each the same size, because data can be very spread out in the smaller numbers and then very close together with the larger values, or vice versa. You can see in the example here that the whisker on the left is a lot larger than the whisker on the right. What that means is the data is more compact in terms of the numbers are a lot closer together towards the upper end than they are on the lower end. Same thing with the box. Again, the box will border the lower and upper quartiles. The median will be the line somewhere inside the box. Again, it doesn't have to be in the middle of the box for it to exist. So just kind of keep that in mind. Each piece is 25%. It doesn't matter if it's perfectly balanced or not. That's not the point of a box and whisker. So let's take a look here at a couple examples here where we do some interpreting and go from there. So here is a box and whisker. It's called a double box and whisker because, well, there's 2 of them. Nice thing about box and whiskers is if you have 2 similar sets of data or more, kind of like the back-to-back stem and leaf plots, they're very easy to stack on each other and compare. So this is dealing with average high temperatures for a year in 2 places. It looks like Atlanta and Orlando. Question A is asking what percentage of the high temperatures in Orlando are greater than 76.5. So here we see 76.5 is the second of these 5 dots. That means that is the lower quartile. That's the Q1. And it wants to know percent that's greater than 76.5. Well, here's how you figure that out. So greater than, I'm going to go to my right, obviously. I have 1, 2, 3 pieces. So I have the first part of the box, the second part of the box, and that whisker at the end. That's all after 76.5. If each of those pieces is 25% and 3 of them come after that 76.5, that means 75% of my data, 75% of these high temperatures are greater than 76.5 degrees. Question B asked, for how many months is Atlanta's average high temperature less than 60? So I go to the Atlanta. So here's 60. I want to be less than 60. There's one piece of my box and whisker that's less than 60. So one piece would be 25%. But the question is, how many months? So what we would have to do is take 25% of, so it said it was the temperature for a year. A year is 12 months. We would take 25% of 12 months. So mathematically, that means you're doing 0.25 times 12, and you get an answer of 3 months. Okay? So some of these questions are going to ask for the percentage, and again, it'll be some multiple of 25. Some of them may ask you to go one step further, where you have to find the percentage but then apply it to the problem itself. So it is important to read these carefully to make sure you're finding the correct information. Let's take a look here at this next example. See some similar interpreting questions here. Class of 28 students took a test. Data is shown in the box and whisker plot. First thing it wants us to find is the interquartile range. Well, as we know, to find the interquartile range, you have to know the upper quartile, the lower quartile, and you subtract them. So I, again, use just Q3 and Q1. That means the same thing as upper and lower quartiles. So I have to look on the box and whisker. The lower quartile is the left side of the box. The upper quartile is the right side of the box. So the upper quartile in this case is 90. The lower quartile is 70. I'd subtract them. My interquartile range would be 20. Part B, give an interval of scores that would include 50% of the data. So 50% of the data means 2 pieces of the box and whisker plot next to each other. That's what would represent an interval of 50%. So if I want to have an interval of scores that include 50% of the data, I need 2 pieces right next to each other. So I have 3 options for this that are all correct. From 65 to 80, that would be 50% because that involves 2 pieces of the box and whisker. So 65 to 80 would represent half the scores. I could also say from 70 to 90. Reason being, both pieces of the box, that would be 25 and 25, that'd be 50%. So 70 to 90 would be 50% of the data. And last but not least, 80 to 100, because it's the right side of the box and the far right whisker, that's 25 and 25, that's 50%. 80 to 100 would also represent 50% of the data. Last question is asking how many students scored at least a 70 on the test. So if we take a look here, here's 70. If I want to be at least a 70, that means I'm going to be greater than 70. So I have 1, 2, 3 pieces of the box and whisker. So again, each is worth 25%. That means 75% scored at least a 70. However, the question's not asking what's the percentage. It wants to know how many students. So I go back to the original problem. 28 students took this test. Well, 75% of them scored at least a 70. That means I need 75% of 28. So again, mathematically, I'm doing 0.75 times 28. The answer would be 21 students. One more example. Again, just to kind of drive the point home on finding all these different pieces of information. So here's a double box and whisker again. Very generic. Question A, which class had the higher median score? So if I'm looking for the median in the box and whisker, I'm looking for the line inside the box. So I'm going to highlight that here in purple. The class that has the higher median would be class 1 because it's further to the right on the number line. So class number 1 has the higher median score. Question B, which class had a wider range of scores? You could technically do this one of two ways. You can technically take the highest minus lowest, find the range that way. If it's obvious visually, which this one, hopefully you recognize it's a pretty obvious visual answer here, you can certainly also do that. If you look at class 2, it goes from one end to the other of the number line, while class 1 doesn't quite do that. So it should be obvious visually that class number 2 has the wider range because it has a lower minimum and a higher maximum than class 1. If you want to prove it mathematically, again, you can just simply do highest minus lowest, take the two endpoints and subtract them. Question C, what percent of students scored above an 80% in class number 1? So again, here's 80%. Percent of students that scored above an 80, one piece, two pieces of the box and whisker are above 80. So if I have two pieces, that would be 25% each. That's a total of 50%. And since it's just asking for the percent of students, that's all I have to do. Question D, how many students scored 50% in class 2? Now, the one thing about the box and whiskers are great at generalizing data, but they don't really give you specific information. The one thing I know, yes, I have a point at 50%, but we really don't know how many students scored a 50%. It could have been one student, it could have been maybe 5 students, maybe this is a really big class. We don't technically know because it's just a singular data point. Box and whiskers aren't really great at giving individual information. So a question like this, we would say something to the effect of not enough information because we just don't know. So that's one of the downfalls of a box and whisker. If you're looking for individual data points, you're not going to get that from a box and whisker. So that's just something to keep in mind with that. That's probably not a question you'll run across in the IXL, but it's just information about it. So with that all being said, 1 IXL again, we're still in level I. BB16, get it to an 80. So again, please be conscious of the fact that we are running out of weeks here in the school year. If you're behind on your IXLs, please make sure you get caught up here very, very soon as we only have a couple of weeks left. Make sure you are staying on top of your assignments for this class and keep your grades up here. So if you have any questions, as always, send me a message on Schoology, shoot me an email, stop by my office hours on Zoom. I'll be more than happy to help you. Otherwise, thanks for watching. Stay safe, stay healthy, and we'll see you next time.